Everyone, welcome to this class. We're still in chapter 2 of book 3. Here we are going to deal with the laws of logarithm. The three fundamental laws of indices that can be stated in their equivalent logarithm form are log mn is equal to log m plus log n. When you have logarithm of two logarithm, the answer is equal to log m plus log n. Second one, log m over n is equal to log m minus log n. Or the final one, log m raised power p is equal to p multiply log m. You can see the indices equivalent here. So we're going to explain it in our notebook. Here are the laws. So log mn is this, exactly what we read in the text, but now we have the indices equivalent. So let's prove this. Log m, let's say log m. There's something I want us to note here. You notice there is no base given to this log. Normally, according to standard, when we are doing the logarithm, I did not see any base. We assume that the base is 10. That's why in our junior class, you see like log this, log that. We now use our table or our calculator. So, or when you are doing log of other bases, you usually state it. So these laws apply if the base are one base. As you can see, they are all in one base. By the virtue of not putting base here, means they are all in one base. So log m, let's say that let's say log m base x now, for example, is equal to a, and log n base x is equal to b. So if you have to change this to indices, we all know how we do it. X raised power a is m. So x raised power a is m. On the other hand, if we have to change this to indices, x raised power b is n, what we did in our last class. So remember, x raised power b is n. So m multiplied by n, which is like mn, is the same thing as xa multiplied by xb. In our law of indices, when two indices multiply each other and they have the same base, the answer is the same base but a plus b. Now we have n is x a plus b. Are we getting it? Now let's convert this thing back to logarithm form. How do we convert to logarithm form? Remember what we did in our last class, where we say, let me give an example, log, let me say this is b, a is equal to c. To convert it to indices is now like what we did here. A raised power c is b. That's a raised power c is b. If you want to convert this back to log, the one that is raised, that has an index, is the base to be log. This one will be the base a. Yc is raised power will be the answer. Yb is the number you're looking for the logarithm. So let me mark this out. So here, if we were to convert this thing back to logarithm, this x will be the base. So I'll have something like log x. Why? What is the indices? Okay, sorry, this is what I'm looking for. The x will be the base, the indices will be the answer, which is a plus b. Why this, like here now, is what we are looking for the logarithm mn. So from here now, we already know a plus b. From here, this is a, this is b. So log x mn is a is log xm, yb is log xn. This is b, this is a. So by this we'll prove the first law. We can also use the same method to prove the second law and the third law. So let's go to prove the second law. Second law says that log m over n, here says that log m over n is equal to log m minus log n. Exactly what we did in the first one. We can say, okay, log m is a, while log n is b. So Let's convert. Let me put x here. So here I will now have x raised to power a is m. If we change it to indices, change this one to indices too, will give me x raised to power b is n. So I can now say, okay, let's do m over n. That's equal to x raised to power a over x raised to power b. And according to the law of indices, when two indices divide each other and they are of the same base, is equal to x raised to power a. The one on top we minus the one below. A will be here, while b will be there. So m over n is now x a minus b. So let's change this thing back to logarithm. The x will be the base, so log x is now the base. This will be what we are looking for, the logarithm. Why this indices is the answer, a minus b. And we all know that this is a. So this is equal to a is log m base x. Why b? This is b, because the minus sign here, log x base n. So this proves the second law. For the third law, you can prove it on your own or ask question in the comment section. Let's start solving examples. So the first example says log 8, that's a, plus log 5. This is our first rule, which says that log m n is equal to log m plus log n. So this is simply log 8 times 5, which is mn. Now it's in this form. We will now take it back to this form. So this is log 40. Number 2, 2 minus log 4. Now remember what I told you, that if you don't see any log here, it means it's logged. The base here is 10. Remember that one. So which log of base 10 will give you 2? That's the first thing you are going to ask yourself. Now let me say log, let's make it visible, x equal to 2. So it is, if you change it to indices, the base raised to power the answer will give you this. So it will be 10 raised to power 2 equal to x. So 10 raised to power 2 is what? 100. So x is equal to 100. So you now continue to be log. Remember what I said. If you want to change it, you understand? This x here is already 100, so it will be log 100 minus log 4. I don't know if you are making sense, because you can't solve it in this form, so I have to change it to log form, and that's why I have to go through this to know what, if I put it in log form, what should be here. And I was able to get the x to be 100. Now, not putting anything here means it's in base 10. When you're having log of base 10, you don't usually put it. So I have to put it here so I can solve. Now I have to bring it back to the normal way it is. So now we have our division rule to deal with. Let me bring it here. Log 100 minus log 4. According to this is negative, so according to this rule, we have the second rule, m over n is equal to log m minus log n. So this one is already on this form, so we take it back, we take it to this form. So this is log 100 over 4, which is log 25. That's your answer. So the next example is log 9 divided by log 3. That's C. We are still using this law. It's already in this form. Okay, let's put it this way. It's already in this form. So I'm supposed to now take it to this form here. Okay, sorry, this one is different. This is division, so I will have log 9 over log, because I made a mistake. This is the log that is dividing, but this rule only apply when the figure here is one that is dividing. So that was the initial mistake I made, so corrected it. Log 3. Now this log 9 can be changed to log 3 raised to power 2 all over log 3. 3 raised to power 2 is 9. Now remember the third law that we did that says log m p is p log m. So that's where you are having this like m, this like p. Let me circle this so it doesn't join with the question. So you have something like 2 log 3 all over log 3. Now log 3 and log 3 will cancel each other. We're only left with 2. So 2 is the answer to this. So the final question is D, which says 2 over 5 log 32. Also, using this law, I can carry this and bring it here. Now it is in this form. I want to take it back to this form. So I'll have log 32 all raised power 2 over 5. And we all know that 32 is the same thing as log 2 raised to power 5 all raised power 2 over 5. And remember the laws of indices. When you open up the bracket, the two indices will multiply each other, so it will be log. If these two indices multiply each other, you have something like 5 times 2 over 5, right? So the 5 will cancel. You are now left with 2. So it will be log 2 square. So you have two ways you can put this answer. You can say it's log 4 because 2 square is 4, or you can apply this rule. Now it's in this form. You can take it back to this form. So this is answer. This is still the answer. And you can take it this way. It will now be 2 log 2. This is another answer. So let's take an exercise and solve, and then we'll use it to round off this topic. So let's solve these examples. The first one says 3 log 2 plus log 20 minus log 1.6. We use our normal rule. First law says that log m n is log m plus log n. Second one, log m over n log m minus log n. Third one, log m raised power p log m. All of them are all here. That's how I have to list it out. Now for this, we use this law. So this 3 will come here. Okay, let me write it out first. 3 log 2 plus log 20 minus log 1.6. So this raised power, it will be log 2 raised to power 3. Now this is plus, so these two will multiply each other. But let me first list it out. Log 20 minus log 1.6. Now I'm going to have log. Using this law here, it will be 2 raised power 3 times 20. Now this negative sign, so I'll use the second law, all over 1.6, all in one log. You see the trick here is now up to 3, so you just combine all of them. You just have one log. The one that is plus will be multiplied, while the one that is negative will divide under. It's not a must that it will only be 2 for it to work. It can also work for more numbers. So I have log 8 times 20 all over 1.6. If you divide this by this, you have you have 0.2, and 0.2 20 divided by 0.2 is 100. So you have log 100, and log 100, because I told you whenever you have a log that doesn't have a base, means that here is 10. So log 100, what would 10 be raised to give you 100? The answer is 2. So 2 is the answer. Then the second example says, number 7, log 8 minus log 4, all divided by log 4 minus log 2. So with this time around, we are applying this rule. Let me outline this rule so it doesn't mix up with my question. We are applying the negative rule here. So it will be log 8 over 4 all over log 4 over 2, since here is negative. So I have log 2 over log 2. So the 2 will cancel each other. The answer to this one is 1. Here now, the next one we are going to solve is variable. They say if log, that's number 9, x minus log 2x minus 1 is equal to 1. Find x. So which law are we using here? We use the second law, negative law. So I have log x all over 2x minus 1. And let me put it in this form. Or is equal to 1. Now let's change this to indices. If you change it to indices, here is 10. 10 raised power 1 is 10. So it will be 10 raised power 1 equal to x over 2x minus 1. So 10 raised power 1 is still 10. 10 is equal to x over 2x minus 1. So we'll cross multiply. It will be 10 raised power 2x minus 1 equal to x. So 20x minus 10 is x. So we are going to, when 10 crosses the equation, because it's negative here, it becomes positive. So you have 20x equal to x plus 10. When x crosses the equation, because it's positive here, it will become negative here. It will be 20x minus x equal to 10. So let's continue here. 20x minus x equal to 10. So 19x is 10. Divide both sides by 19. X will now be 10 over 19. This is your final answer. So this is all for the logarithm. And with this, we are done with chapter 2 of book 3. You can solve the other exercises on your own. And if you have any challenge, do well to drop it in the comment section. Thank you and see you in the next class.